sure. E equals MC squared, my boys. E equals MC squared. The boldest declaration anybody ever dared. No matter what we'd done, the world could never be prepared for the man who helped us understand that E equals MC squared. You're rushing and you're daydreaming and you drive right through a light when the policeman pulls you over.
Good evening, weekly viewers, and thank you for tuning in to the most anticipated episode of the 2,344th series, Physics in History. Tonight we'll be analyzing the monumental crash, the crash of 1506. Here we are, 500 years later, at the very site of the crash. Of course, back then, 50 years before the birth of Sir Isaac Newton, only physics radicals such as Paul Hewitt I existed. The civilians were only exposed to weekly lectures given by the great Paul Hewitt. The people were puzzled by motion and its attributes. The crash of 1506 created feelings of interest and provoked many questions regarding physics. Today we have the experts, Dr. Marielle Chuchurita, Dr. Lana Whitweiler, and myself, Dr. Elizabeth Hornswoggle, critiquing third laws and principles such as gravity.
Dusk was falling on that fateful October evening in 1506. 3 young women were walking back to their vehicle after attending Paul Hewitt the first physics lecture. They didn't know that they would never emerge from the vehicle again.
I don't get it. When Burl moved to the other side of the scaffold, why didn't Paul fall?
Oh, Judy, you're so naive. It's the same principle explaining why you can walk through a wall if you dedicate your life to trying to.
So you're saying if I jumped up and down enough times, I'd be floating in the atmosphere?
Ah, yes! The victims of the crash were puzzled by the great Paul's philosophy and those suggested by the local townsperson Eureka Jurgish. Little did they know what was about to happen. I mean, this ideology known as physics, it's just so radical. I mean, we move, so what? There can't be that much to it.
What these people didn't understand was the nature of forces and the present laws of motion. Aristotle's law of falling bodies states the rate of a fall of a body depends on its mass. The heavier the body, the faster it falls. Aristotle also applied this to the fact that an object's velocity depends on the force pushing it. We know today that acceleration equals force over mass, not velocity. Therefore, the people that believed in Aristotle's findings were only half correct. Newton would later prove them wrong.
We are moving. Look out the window. You can see the cars in motion. I step on the gas pedal, we go faster. I hit the brake, we slow down. I turn, we change direction. Changing direction, that means our speed is changing.
No, Agnes, our velocity is changing. Speed is just a number. Velocity describes magnitude and direction.
So then the ball that I'm throwing, is its velocity changing when the car turns?
Don't throw anything in my car.
Well, I don't know. I guess the only way we could find out is if you throw the ball.
Aha! That raises an interesting question. It's a question that is indeed going places in the history of physics. Relativity, as explained in Newtonian terms, states that whether you are at rest or in uniform velocity, it makes no difference. We cannot distinguish between a body at rest and a body with a uniform velocity. Only on a relative basis can we differentiate between the two. Let's consider the idea that a baseball team is on a bus going to their game. The pitcher decides he wants to warm up and gets in the aisle with the catcher to do some practice throws. It doesn't matter whether the pitcher is pitching on the bus or on the ground, the pitched balls will have the same velocity. It's all relative.
After all, when I throw this ball, it comes straight back to my hand. Why?
Gravity, you dumb beep! Gravity. Gravity is defined as 10 meters per second per second. The pull of the Earth is defined as that acceleration of gravity, 10 meters per second squared. Of course, Newton's third law may confuse the average non-physics type, but we hold the answer to those questions. Earth pulls on ball, ... and what do we get? Ball pulls on Earth. Same, equal and opposite reaction. I say you just throw it.
I know what I'll do. I'll throw it forward, see if it comes backwards and hits me, or it goes and hits Agnes.
So either way, one of us is getting a bruise today. Wait a minute, I know what's going to happen. It will...
Indeed, ladies and gentlemen, you can predict what happened next. The ball winds up hitting Agnes, and wham! The ball forces traction upon poor Agnes, and the car smooshed and whammed into a tree. It was devastating. The sounds that replay in my mind over and over again are dead. 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 Dead! Dead! We've already covered how gravity, relativity, and Newtonian laws have applied to the crash of 1506. So here we are today to ask frictionologist Dr. Hard to Move just how friction played a role in the Great Crash. So tell me, how did the concept of a free body diagram play a role in the crash of 1506?
Well, you have your perpendicular forces, which is dependent on gravity and a body's mass. You know, force equals mass over gravity. You know what I'm talking about?
Well, yes, of course, after all, we are all physics types.
Also, in this free body diagram, there are horizontal forces which are calculated by figuring out the net force between applied force and frictional force. The main focus we are concerned with in this system is the horizontal forces, frictional force and applied force.
When I was a little girl yesterday, my dad took me to the store and they said, "Boy, start shaking the candy tree." And as they were shaking it, a car came and crashed into it, which made the candy fall even quicker. I was quite happy, but everyone else died.
Hello, my name is Lawrence Higginby III, and I am here tonight to recount the tale of my great Aunt Agnes's passing in the crash of 1506. Oh yes, she was there, and yes, she did meet her maker on that fateful October evening. If only she were wearing a seat belt, perhaps she wouldn't have perished. But no, she did, and we all still miss her.
So either way, one of us is getting a bruise today. Wait a minute, I know what's going to happen.
Do it, girlie. I say you just throw it. I say you just throw it. I say you just throw it. Just throw the damn thing, please. What?
Are you filming?
Older people don't curse. The sounds that replay in my mind are dead. Dead.
I can't bring it.
Oh yes, she was there.
Oh, dear, Agnes. Right here. Right here.
Cheers. Not quite so squishy as it used to be.
E equals MC MC squared.
She's on her!
This declaration.
It's an inquiry.
Exposed by weekly wax of blah.
I am acting normal. This is in the history. And Wallet Chickadee. That's not my name, is it?
Mariana shoot every time. Elizabeth Woods.